we can actually see evolution with beautiful examples that are quite recent. I want you to think of evolution as something that just happened in the past, though of course it takes many, many years in order for evolution to take place. It's not immediate. It can be quite apparent and recent with this example that I'm going to give you. So here's an example, mosquitoes and evolution. Malaria is a disease caused by the Plasmodium parasite. And so here I can see a blood smear. There's a blood smear here. And what that means is I've taken somebody's blood and smeared it across a microscope slide. And then now I'm looking at the blood smear underneath the microscope. And let me get my pointer. All these little kind of round structures here with a little bit of hollowness. They look like little donuts, if you will. Those are blood cells, red blood cells. And actually this kind of dark purple looking thing here, that's actually the Plasmodium parasite. It's not going to happen in the normal individual. I don't, at least I think I don't have the Plasmodium parasite in my blood. I don't. Individuals where that parasite infects their blood is called malaria. The disease is called malaria. And I won't get into too much detail what malaria is, but the parasite causes this disease. The parasite is transmitted by a mosquito. So there's a mosquito having its blood meal in an individual. Well, if that individual has this parasite in their blood, that mosquito is going to suck it up and then go, and when they have their blood meal on another individual, they're going to transmit that parasite to that individual. So that mosquito is transmitting that parasite. It's known as a vector. So, okay. The WHO, the World Health Organization, in 1955 launched a campaign. They wanted to eradicate this terrible disease, malaria. And so they thought, all right, let's go ahead and focus on a strategy. Since the parasite is transmitted by mosquitoes, let's go ahead and kill off mosquitoes. Sounds great. Mosquitoes are terrible. I'm all for getting rid of mosquitoes. I know that affecting ecosystems, we shouldn't manipulate species too much. For me, get rid of mosquitoes. So this sounds like a great idea, doesn't it? Let's get rid of the mosquitoes, get rid of the parasite, we'll get rid of malaria. All right, get rid of the mosquitoes. And so they go ahead and develop a pesticide, DDT, that is going to kill mosquitoes. And a massive spraying operation was taken place, or it did take place in 1955 in order to get rid of this malaria. So before I go on to the next bullet point here, 1935, let's look at before DDT spraying. This image here is showing me the distribution of mosquitoes. Distribution of mosquitoes. Okay, it looks like over here in this portion of Southern United States, Central America, we have a lot of mosquitoes. Definitely South America, we have a plethora of them. Okay, so in 1955, they went ahead and sprayed DDT. Great, we see a huge reduction in mosquito populations. I actually don't see too many mosquitoes occurring compared to 1935. All right, but if we go ahead and jumpstart from 1955 to 1995, and this is true, this really did happen. So 1995, well, check it. All the mosquitoes came back like they were in 1935. They all came back. In fact, all the mosquitoes, can't get rid of them, so all the mosquitoes came back DDT resistant. So what does that mean? It means that these mosquitoes that survived the massive DDT spraying, so that pesticide, some mosquitoes survived that. Well, their offspring then could survive DDT even better than the other offspring. They were naturally selected to be resistant to DDT. So now, instead of getting rid of mosquitoes, all we did was create DDT resistant populations. This is an example of evolution in action and a big learning experience for WHO to not mess with ecosystems so readily and to always think about these consequences. It's a massive consequence that is our fault as humans. Okay. So in evolution, we have a timeline historically. Humans have always considered this concept, maybe not evolution, but as far as why things are the way they are, why we have certain species existing, why other species don't exist anymore. Faith plays a huge part in seeing the world and why it's created in the way that it is. And so faith, explanations, started out our curiosity with this concept. Then we moved on to philosophical explanations, and kind of these are occurring at the same time, if you will. Philosophical explanations got us a little bit closer to the theory of evolution that I'm going to teach you today. And philosophical explanations are based on reason. Aristotle is a huge contributor to the philosophical component of the theory of evolution. Why do these species exist? Instead of answering how, because science wasn't really giving us that answer yet, didn't really exist until the scientific method was put into play. And now we have a more scientific explanation on the theory of evolution. I kind of hesitate using that because we didn't label it that yet. There's a historical timeline that takes place with that, which I'm going to teach you in a bit. And so with scientific explanations, we actually, and I taught you guys the scientific theory, we have a question or observe a problem. We get facts. These are our observations. This is what we really see. We propose a theory, and we use reason in order to propose this theory. So this is where philosophy helps us with this concept. So we wouldn't have scientific explanations without the philosophical component, which is why it's important. And then with testing, we get our results, and we either concur with our original hypothesis or we improve on that theory